Welcome back. Today we're continuing to make the doors for our bookcase. Today's the turn of the raised panels themselves. That sounds interesting. Stick around. In last week's episode we made the frames for our raised panel doors to go on the bookcase behind me, and today I want to turn our attention to the raised panels. But for now, let's work out how we size up the panels. You remember that in last week's episode we made this rather fetching frame for our doors, and you remember we worked out the overall sizes: 1012mm high by 497mm wide. And we looked especially how we made up the sizes for these rails in the middle. I now want to turn the attention to these two panels that we've got here, and we're going to cut those panels from the pine board that you see underneath the frame. So let's have a look at what size the panels need to be. The first dimension I need to worry about is the width of the panels. Now we know that we were aiming for 369, but we also recognise that we may not get accurate cutting on the size of the rail itself, and it's the size of the rail that dictates this internal dimension. So don't just rely on our calculated figure, we'll actually do a measurement on the frame to see what that figure really is. So at the top here I'm getting a figure of 372, and on the base here I'm getting a figure of 372. So we know we're square, but the actual dimension is 372 millimeters. So that's what we're going to work for, not 369. The second dimension is how long do I want these panels to be. Now we don't know that yet, but what we do know is we made a design decision that we're going to put this middle rail, this cross rail, in the center of the panel. So if I find the center point on my style, find the center point of my rail and line that up, then that will give me the length of my panels, and I can measure that directly from the frame. And again, we'll take an exact measurement from here. So my overall panel is 1013 long. So although we were aiming for 1012, we've actually ended up with 1013. Now half of 1013 is 506.5. So I can now measure up 506.5, and 506 is there, so the half is going to be round about there, and then I'll just square that line across like that. So that's now my center point of my door. I now want to work out the width of this, and we were going for a width of 64 millimeters, and we've actually ended up with 64 millimeters. So I therefore want a center point on this rail of 32 millimeters, which is there. So I can now line the middle rail up with that center point. Which is there. So now in order to find the length of my panels, I can simply measure this inside distance, and if we've done our job well, they should be equal. So this one here is 408, so 408, and this end is 410. So this is obviously not perfectly centered, but that's okay, because I know this is 410 and I know this is 408. So if I made both my panel lengths 409, when I come to assemble the door, I know this point will be center. So that's good, we'll accept 409. Now don't forget that inside these rails we've got this groove, this mortise if you will, and that mortise is 12 millimeters deep. So we've got a 12 millimeter mortise inside each of the rails. So if I made my panel exactly 409 long, or my panel exactly 372 wide, then the panel will fall through the doors. So we've got to add some dimensions to these two figures so it sits inside this tenon inside the rails and the equal tenon inside the stiles. If I add 12mm onto this, that'll be very, very tight inside the door frame, and therefore it won't really allow for any expansion. The minute it starts to expand from where it is today, then that will start to push the frame apart. But equally, I don't want too little, so when it contracts, it falls out of the frame. So I'm going to add 10mm for each mortise. So my 372 plus a mortise on one side plus a mortise on the second side would equal 382, 392 wide. And my length would be 409 plus 10 on the top and 10 on the bottom, which equals 429 long. And it's that easy to work out the size of the panels. Measure those internal dimensions and add some on for the mortise inside your stiles and rails, but don't make it too tight and don't make it too loose. And I tend to find that 2mm away from your total gap, from the inside of one mortise to the inside of another mortise, allow 2mm either side, gives you a good place to be. So job one is we're going to rip this board down to 392. And I'll do what I normally do. I'll cut off this edge so I get a known edge, and I'll use as my reference edge. Then I'll measure 392 and I'll rip the entire board. Now, in the same way that we wanted the grain to flow across these drawers so it looks like a single piece of wood visually, I also want the grain of the panels to flow through these doors. So when you stand back, you'll see the grain flowing through this door, you'll see the grain flowing across here, and you'll see the grain flowing through here. And that just makes it visually appealing for your eye. And again, it's one of those things that nobody will ever notice, but it will look nice and people won't work out why. If you don't do that and you tend to have the different grains contrasting, it still looks okay, and you may want to do that as a design feature, but your eye doesn't tend to flow around the furniture in the same way, and it has these blocks and these breaks, and it just doesn't feel as comfortable. And it's a difference of somebody wanting to caress and touch and get tactile with the furniture, and somebody saying, yeah, that's nice, and then moving on. So we're going to make sure our grain flows. We'll rip it to width, and then we'll cross cut one panel, two panel, one panel, two panel. Keep the orientation, and then the grain will flow nicely. I'll crack on and get these cut out. Now there's all our panels cut to width and cut to length, and you can see I've marked them up, panel A and panel B. Nothing complicated, panel A, panel B, panel C and panel D, just to keep the orientation of the grain correct. And I'm just putting an arrow up so I know that that's the top of my board and that's the top of my board, so I now can see the grain direction. And as I was cutting these panels out, I was just thinking through what would be my face, and I don't particularly want again this run here showing on the final surface at the front, hence choosing those sides. So good, with that done, we can now make the raised panel. To make a raised panel on a router table, you use a special bit, and the bit is cleverly known as a raised panel bit. Makes sense. There's two designs. There's this design here, and there's this design here. Now the difference between these two bits, apart from the colour, is one is used in a horizontal position and one is used in a vertical position. When you're using the horizontal raised panel bit, your board is laid flat on your router table and you pass it across the cutter in this way, with the edge running on the bearing. When you're using the vertical cutter, your board is orientated like this and you pass it across the front of the router bit like this, and there's no bearing to guide you, so it's your fence that dictates how deep that router bit cuts into your panel. On your horizontal cutter, it's the height of the router bit in relationship to your material that dictates how deep you cut into your panel. And what I mean by cut into your panel, how raised the raised panel is going to be. Now typically you want the front of your raised panel, the highest point, to be level with the outside of your rails. So you take some test cuts and you get to that position. Now obviously this is 18mm thick pine. I want the front of my panel to be level with the frame on my door. I need to reduce the thickness of the material on the face side down to a point where, once that's inserted into the groove, the top is level with the frame. So I can measure from the top of the tenon to the face of the material, and that is going to be, on this particular one, 5mm. So I either need to raise the height of this router bit so it's cutting 5mm into the edge of the board, or set the fence with this type of router bit so it's cutting 5mm into the board. Now the problem that you're going to have with the CMS table using the OF1400 is this type of horizontal bit will not fit into the table or indeed the router base. So this type of bit becomes your best option. The problem with this type of bit is you're trying to support the board vertically and pass it across the face, and on the CMS table there are no fingerboards to make sure you get consistent pressure, and as you tend to focus on this board not tipping too much, you'll find that your pressure varies on the router bit and you get an uneven cut on your panel. So we need to modify our CMS to find a way of introducing a fingerboard so we can use this type of bit with the OF1400 in the CMS but still get a smooth cut. So before we make any cuts, we need to find a way of improvising a fingerboard onto the CMS. Let's look at that. If we look at the profile of this router bit, it's this flat surface here from there to there that is going to dictate the length of the tenon that goes inside the channel, and we know that we want that to be somewhere between 10 and 12mm because that was the depth of the groove that we cut. So if I measure that, this is actually bang on 10mm, so that's good. So I want to line the base part of the cut up with the surface of the table, which is there. So I now am going to get a 10mm tenon around my door, which is what we're looking for. I then want to bring my fence in, and I want to make sure that the gap in my fence where the dust collection is wide enough so it doesn't get caught on that router bit, and that looks good to me. Now we know that we want to ideally offset the front surface of my panel to the top of the inside tenon by 5mm. So ideally this flat part of my router bit here wants to be 5mm from the fence. Now it can be more than 5mm. 5mm will make the surface of my panel flush with the outside of my rails. If we go higher for 6mm, then the surface of my panel will be a millimetre below the outside of the rail, and that's okay. So we're going to find something that looks pretty, and we'll start off by looking for 5mm, and as a guess that is going to be somewhere around about there. Now that position, that is 5.4mm away from the fence, so we'll give that a test cut and see what we think. So I've got a scrap piece of wood that we will use to make the test cut, and all we're going to do is to take that across the front of the panel and see what it looks like. So there you have the profile with that set where it is. So the question is, will that look nice enough? Now if I come in with our raised panel and the actual rail from the frame, can you see there's a slight gap between this surface here and the top of that mortise. So when that comes together, this panel will raise up to fill that gap, and this will be slightly higher than your frame. So to correct that, I want to close that gap up, so my fence will need to come forward by that distance, which is not an awful lot, probably about 0.5 millimetre. And now we'll make another test cut. Now in terms of that cut, that's okay. It's leaving me a very slight gap, much smaller gap than we had before. And don't forget that this is chamfered, so this board will close in onto that chamfer and hold it all nice and tight. The next thing is this high enough in the table? So I want to look at the length of this tenon compared with the length of this mortise, and it's quite hard to visualise. Now don't forget we've left a 2 millimetre clearance on this board, and you can see that this edge here is pretty much lined up with the end of that tenon, which means that this board is going to fit in something like that once we assemble the door, and that looks pretty good to me. Not sure if it's going to turn up on the camera, but if you cast your eyes down here, you can see that it starts to wave here and there, and that's because as I was taking this across the board, it's very hard on a large board to keep even pressure onto that router bit, and every movement on your board alters the depth of cut of this profile, and that's why you end up with an unclean edge, and that will show in your final joinery. And what you normally have is a set of fingers here that puts equal pressure on the board as you're passing it across, so it can't tip in this direction. It's trapped between the fingers of a featherboard and the fence surface here, and that gives you equal pressure, and that guarantees that you have a nice cut and you don't have any of these wavy lines here that start to show up on that edge. And it's important that that edge is pristine for the final look and fit of the panel. So we now need to improvise and make some sort of featherboard for the CMS, because it doesn't come with anything. Now the good thing about the crown moulding is it comes with a T-slot, so it clamps firmly into position, it's flat and parallel to the surface of my CMS, and it's also got a T-slot that will take a Festool clamp. My Incra fence has also got this top fence that gives me additional support. So I can use these two features to make sure I always have consistent pressure as my material's going across the cut. And in theory, that gives me the accuracy I'm looking for. I'm going to come in with the boards I'm actually going to use, because I know that all these edges are nice and square and I know that's the right size material. And I'm going to drop them either side of that cutter. Being careful not to catch the boards on the cutter because I don't want to damage them. I'm going to come in with an old scrap piece of wood, and this is the one we actually used the other day to test our profiles, so it's got a bit of a tenon on it, and I'm going to gently push that up to the base of those boards. Not hard, just ever so lightly. And then with that, making sure it's resting on both the boards, I'm going to clamp that into position. And now that's going to allow me to slide my boards into the cut, and the tongue on this piece of material will make sure I get equal pressure on the cutter. I now want to take this fence and bring it forward so it's supporting the back of this board. Not pushing the board forward, just giving it support, which is there. Now in theory, I can now slide this board through the cut. This piece of wood will act like a featherboard, putting pressure there. My top fence will stop me pivoting this board backwards and forwards, and I can just lightly steer this through, more of a driver, actually more of a passenger in this activity. And that should give me a clean, crisp cut on this board. So we'll come in with this scrap piece of wood and we'll just turn this into a raised panel. Technique as always, do the cross grain first, then do with the grain, then cross the grain, and then with the grain, and that will repair any damage happening to the board due to tear out. I've never used this bit before. I don't know how violent it's going to be. I've got the router set to a midpoint in terms of speed. Let's give it a go. And that's worked. That's made a beautiful raised panel door. All these lines are really clean and crisp, and it's a nice profile. And in theory, it should be a nice fit to the frame, and that will be. At some point, we'll modify this idea, and we will make a featherboard for using with the CMS. But it'll be the same sort of idea. I'll probably get a couple of Festool knobs to clamp it to here with slots cut in so I can slide it backwards and forward to adjust the tension. And I'll probably route a number of angled fingers in here that will also help prevent kickback. But basically that's the concept I'll be going for. So that's a simple modification to the CMS to solve one of its shortfalls, not having a fingerboard. Let's get our panels cut. When you're cutting raised panels, obviously your face side is going to go against the cutter. So across the grain, with the grain, across the grain, with the grain, to clean it all up. So what you end up with are two rather nice raised panel doors, and it's worth taking your time, and you can see that this profile round the edge is pristine. You're never going to see better than that, and all these angles here on the corner are perfectly 45 degrees, and this tenon is absolutely beautiful. Now this is still not going to fit into our rails because we have to take some material off the back of the door to bring it down to the width of this profile. So this is the back of the panel and this is the back of the frame. You can see hopefully that this edge here where it's raised up is the front of my tenon, and can you see that that is lined up with the inside edge of that mortise in the frame. So we now need to route a profile on the back of the door that will finish off this tenon, and that profile will need to come down to somewhere about there where that mark is. So I want to take out this material here. So we'll just use a standard dado cutter in the router table and take it down to that height. And again, we'll make a test cut first of all to look for fit, and then we'll go ahead and cut our panels. So I'm just looking in my vast collection of router bits which one is going to be the best for me, and ideally I want to emulate this part of the profile we've got here on the front. So this one is way too narrow, this one is even narrower, so I'm going to go ahead with this one which is slightly too big, and I don't mind it being slightly too big on the back of the panel. It's not going to be seen, and if it is seen, it's going to be a nice, clean, pristine line all the way around. So we'll go ahead and we will use this router bit and we'll set it for a depth of cut that will take that amount of material out. I'm now going to be cutting the boards in a horizontal position, so I want some support for this, so I'm going to drop on the mitre table. And I'm going to bring in the fence to give me a distance that's more or less that point to that point, and that's not got to be super accurate. As long as it's ever so slightly larger than that cut, we are in good shape, and that's going to do there. Just check my mitre gauge is clear of the cut, and we'll lock that into place there, and we'll check to make sure that we're square to the fence, and unsurprisingly we are. Now I'm going to come back in with my test board, and we're going to cut this time on the back of the board so the profile is up. Same technique, we're going to do the end grain, cross grain, the end grain and the cross grain, and then that should give us a test piece, and we'll see how we get on. And as we thought, that is too tight, so I'm going to raise up this router bit by about, oh wow, nearly a millimetre. Okay. And that should now be perfect, and it is. So that's looking good. So we've got the nice profile on the front. It's not too loose, it's not rattling around, which is what we want, but it's loose enough where this can float backwards and forwards quite easy as this panel expands and contracts. And on the back we've got a relatively nice joint. Don't forget this board wasn't prepared, it's just an offcut, but you can see we've got that joint, and if it does open up over time it still gives you a nice clean line at the back, and that's all nice and flush as well. So that's good to go. So we'll go ahead and cut our panels with the router bit in that position. And now, all things being equal, this should go together really quite well. Bottom frame, middle frame, side styles, flush up the ends, make sure it's all nice and tight, make sure it's all nice and firm and compressed, and there you have it, a raised panel door. So now what I want to be able to do is to glue this together, and then it's ready for fitting. That's simple, making a raised panel door demystified. Next job is I need to glue that up. Now when we come to glue up, we do not put any glue at all on these panels. We're only gluing the joints in the frame. This one, this one, this one, this one, and this one, and this one. There's no glue at all on those internal panels. You want those panels to be able to float back and to inside the frame. That's exactly the purpose of it. So the frame gives you your final dimensions. The floating panel allows for expansion and contraction of wood. So you do not glue in the panels. Before I do the glue, however, I want to put a finish, a coat of finish that I'm going to use on the bookcase on the panels. The reason for that is if I do it now and those panels expand and contract, all you'll ever see is a finished surface. If I glue the door together and then put the finish on, if that panel shrinks, then you'll see a strip of untreated wood appearing around it. That doesn't look very professional. So I'll go ahead and put a couple of coats of finish on the panels, and then I'll glue it up. And next time round, we'll look at putting the profile on the outside of the door and fitting in them to the unit. See you next time.